It's 3 o'clock. And we're doing ThinkTech Talks. We're talking about forecasting weather and climate and hazards in Hawaii with the National Disaster Preparedness Training Center. Okay, and that means Karl Kim, Owen Shieh, meteorologist, and Tom Bedard. Okay, this is fun. But let's have our conversation that we had before first. There are 3 parts to the show. So in the first part, we're going to get to meet you guys and the National Disaster Preparedness Training Center. I'm going to get to meet the 2 storms, not 1, but 2 that are out there threatening. That's what we're going to do the first one, right? The second one, we're going to talk about your science, the science of forecasting and how far it's come. And talk about some of the vectors, you know, like, for example, El Nino, big vector, and climate change, to the extent that's a vector, in what's going on now and what's likely to happen in the future. You know what I always say, when I walk out the door and I see a beautiful day, I say, oh, it's a beautiful day, one day closer to a really bad storm. It's a half empty kind of approach to things. Okay, and the third is what we, all of us and the public, can do about it. We're going to entitle that part of this episode, Planet of the Adapters. Okay. Better adapter than raptor. You know? Right. Okay, then we're going to offer you guys an opportunity to talk to the public and tell them whatever you want to leave, what advice you want to make, professionally and maybe personally, who knows. Okay, so let's begin with you, Karl. How did you get involved in this business about predicting weather and hazards and climate change?
Well, Jay, as you know, I'm an urban planning professor at the University of Hawaii, and I also direct the National Disaster Preparedness Training Center. It's a FEMA Homeland Security funded center at the University of Hawaii, which develops and delivers training courses on natural hazards, on coastal communities, on islands and territories. We have a big emphasis on weather, and because we have these 2 storms in the Pacific, I thought instead of talking about Jane Jacobs and cities,
we'll do that later. You promised me.
I bring our weather guys in, and we would talk about these 2 storms. And so I have our lead meteorologist, Owen Shieh, and Tom Bedard, who's also on our meteorology team as well too. And so that's why we're here.
Okay, and don't forget that you can participate in this conversation by asking questions or making comments on Twitter. We have a Twitter feed right here, and you can send us a tweet at ThinkTech HR, which says that on the screen. Yeah, it's serious. Okay. Owen, give us a bio, will you?
Sure. So yeah, my name is Owen Shieh, and I'm a meteorologist by training. I actually was born and raised in Florida, so I grew up having hurricanes threaten me quite regularly. And so that's where I got my interest in meteorology. And I decided to pursue a career in meteorology because I've always been interested in not just the weather, but also its impacts on humanity. It's the part of nature that we have to live with every day, and yet it's something that we can't overcome. You know, we can build technologies, we can build a lot of different types of tools to help us adapt, and yet weather is something that still destroys the things we make. Yeah. You know, and so to me, it's the capstone of the challenges that we as humanity faces. Yeah. And so that's why I'm interested in the meteorology side and also the impact side of severe weather.
Something about you can't fool with Mother Nature.
Right, exactly.
But you can make her angry.
Yes.
Okay, Tom, what about you? Give us a bio.
Yeah, I'd like to start off and say that I think I'm the luckiest guy in the world to come out and get a degree in meteorology and have my first job be with NDPTC in Hawaii. So I got my degree from Penn State and spent 4 cruel years in the worst winters I've ever had in my life.
How nice.
I did not think it could get any colder than it did, and then the first job that I had was right out in Hawaii, so it was beautiful. My interest in weather did not come from tropical cyclones. It came originally from growing up in St. Louis, Missouri, and having the worst terror in the world of hearing tornado sirens in the middle of the night. Yeah. So then we moved to Oregon, we moved to Texas, to New York, and I got to see natural disasters from every perspective of the United States. And then was lucky enough to be an EMT for 4 years at Penn State and develop this interest in seeing what happens when you've got weather information that's not displayed correctly. To get to interact with rural communities that don't understand weather and don't react properly, and you have this disaster born. There's no such thing as a natural disaster, just these natural hazards that we do understand quite well, and the human nature that we don't understand quite well enough yet. So I was lucky enough to come here and work with Owen. I've been here for close to a year, and it's been a very exciting period.
You guys are really very lucky. I mean, in the sense that, you know, you're in an area which has got to be expanding, both on the science and the technological side, but also on the climate change side. I mean, it's, you're going to be in such great demand. You're going to make millions. They're going to come to you from all over the world asking your opinion on every climate change issue. Watch, you'll see. I hope you still talk to me.
We will.
Thank you, Karl. So, okay, so how do you practice your art or science, as the case may be?
Wow. It's an art and science now, right?
All of science is an art.
Right. Well,
Forgive me that.
right. Well, I mean, for us, what we're really all about is developing training and educational courses, which focus on these natural hazards. And what we try to do is combine together the best possible science with policies and decision-making. And what we try to do is study different aspects of storms and weather, and what we can do to make our communities better able to weather storms, to recover quickly after storms have occurred, and ensure that our economies, our livelihoods, our businesses can continue and function in spite of bad weather or changes in the weather.
Yeah.
So that's what we're about.
It's the perfect connection for you, isn't it? I mean, you started out with urban
Right.
planning and design, which requires you to think, put your arms around the city, the community as a concept, as a phenomenon. And this now, especially in our time, is a way to save the city, actually, and to relate to the city, because you can't do meteorology, can't do national preparedness, training without understanding, without the city, without relating to the city.
Well, I mean, there's so many things that we can do at the level of the building itself, in terms of building design, the materials that we're using, how we're constructing buildings, also in terms of siting buildings, where we're locating them, planning them, designing them. And there's lots of things that we can do in communities to make them more resilient. And so that's a good part of what we're doing. But a chunk of what we're trying to do is to straddle events like this storm that's approaching Hawaii, and then also kind of longer-term events, changes across the season. We're going to talk a little bit later today about El Nino or climate change, and I think we have to look at things at different scales, not just physical scales, but time scales as well too. But anyway, so I think we should start by talking about these storms.
Yeah,
because
perfect, the perfect segue.
Right.
So, let me tell you this, that if these storms were a real threat, we would have started talking to them about it on minute one. So you can tell already that they're not that great a threat. But why don't we report on exactly what level of threat we have here? Guillermo.
Yes, Tropical Storm Guillermo. It used to be a hurricane, and for several days it was approaching the Hawaiian Islands, and it's still getting closer, but the track has deviated to the right of the main chain of
That'd be
Hawaiian
north.
Islands. Right, so to the north. So right now the official forecast from the Central Pacific Hurricane Center shows the storm essentially passing to the north and east of the Hawaiian Islands. So we'll still get some indirect impacts, such as higher surf. There's a high surf advisory out right now for east-facing shores. And also, as of this morning, there was a tropical storm watch in effect for Big Island and Maui County, but the Central Pacific Hurricane Center mentioned that that might need to be canceled. So the threat is diminishing relative to what was expected before. But we'll still get some indirect impacts.
So the track, just on a momentum basis, was pretty much right over Oahu there for a while, or just a little wee north of Oahu, which would have meant really bad weather for us.
Right, so the official forecast track, and when you see these cones, the forecast cones online or on TV, the official forecast track has to be there for forecast verification purposes, but the forecasters always try to emphasize that you shouldn't pay attention to the exact dots where they're supposed to be, because the farther you go out into the future, the more uncertain the event is. And so yes, even though the black line may have been over Oahu, that doesn't really show the actual uncertainty behind it. So yeah, in general, a few days ago, the forecast track took it toward Hawaii. but we really couldn't pinpoint exactly which island it would hit.
Just as easily, it could have come straight over the studio. Am I right? I mean, why didn't it come straight over the studio? What factors were in play to change the track this way or that way or straight ahead?
So, and that's the challenge. You mentioned art and science earlier. This is the exact analogy for that in weather. We don't understand exactly where all the winds are blowing, how they're all blowing around the tropical storm. And so the science part of it is ingesting the data that we do have from satellites, from different types of instruments. But the art part is filling in the gaps in between. And so that's why we have human forecasters trying to interpret the gaps in data. And what we didn't understand fully, the picture several days ago, is exactly whether or not this high pressure system to the north of Hawaii, the one that gives us the trade winds normally, whether or not that would weaken in a certain part and drive the storm northward, or if it would stay intact and drive the storm more westward toward the islands. And the former case turned out to be what's happening. And because of that uncertainty, the best thing is to show that area of possibility of it hitting. But it ended up turning to the north because the high pressure system weakened a little bit more. And so the storm kind of followed that pattern.
So if this is all, a little magic here, why isn't it possible that the storm could change its mind, Mother Nature? And all of a sudden, right now, today's Tuesday, the anticipated ETA was Wednesday, why couldn't it make a southern jog, a 90-degree turn, and just head for us? I mean, Mother Nature, who knows why? Couldn't this happen?
It could. So we aren't completely out of the hazard or the threat area. That's something I'd like to emphasize is everything is in probabilities. And so even though the primary threat area is going to remain north and east of us, there's still always a chance that the storm could turn. But we are getting better and better now with our computer modeling, with our forecasting ability to be able to catch these turns before they happen. It's the intensity part, how strong it will be, is the part that we're still struggling to try to understand. But track, we're getting better and better at every year.
But the intensity could also change, and we would have no really tight, accurate way of saying how fast it'll be, how intense it'll be.
Right. So intensity is a bigger challenge because, first of all, we don't have quite as much data inside the hurricane to be able to understand the exact structure of it. But also, how that will change in the future depends on where the storm will go. So intensity depends on the track. So if you can't get the track right completely, your intensity is going to be off quite significantly. And so the storm is a perfect example. It's actually hanging on to its intensity a little bit longer than we expected. We thought it would weaken pretty quickly in the last few days, but it's been hanging on, and we still expect it to weaken with time in the next few days. But it's been doing its part in holding us all together.
But you have to go through this, right? I mean, this is not an option. You can't at some point say, stand down, no problem. We're not going to follow this anymore because it could snap back somehow, and
right.
And that would not be good for the community.
Exactly. So the public should heed watches and warnings whenever they're issued, and pay attention to the forecast. And always, it is hurricane season, and it will last for several more months. And it's very important for the public to make sure that they always have supplies on hand in case another storm like this comes our way, which it very well could.
That's what we learned from the Department of Health just a few minutes ago. Okay, we're going to take a short break, and then we'll talk about the other storm that's threatening us, and see if there's lessons we can draw between the two of them. Ooh. It's Karl Kim, Owen Shieh, and Tom Bedard talking about forecasting weather, climate, and hazards. We have to define hazards here on ThinkTech Talks. We'll be right back. You'll see, I promise, yeah.
Hi, I'm Ethan Allen. I host Likeable Science on ThinkTech Hawaii, and I do this because I care about science literacy in Hawaii. I want to spread the understanding that science is a vital and interesting part of everyone's life. I want to make sure the broadest possible spectrum of people understand the beauty and the value of science and realize that science plays out each and every day of their lives. I want you to understand that science is fun. So we bring on to this show each week guests who are scientists, from astronomers to zoologists, And we talk about what they do and how they do it. But most importantly, we talk about why you should care about their work, why you should see that their work has value and impact on your life. So I hope you'll join us Fridays, 1 p.m. here on ThinkTech Hawaii. You can watch us via live stream. You can watch us recorded on Olelo, and you can see us each week. We hope you'll join us.
One, we're back. See? Magic. Okay, so there's this other storm. This storm is down, where is it, in Saipan, near Okinawa, and we haven't heard much about that. Let's hear about it now. Where is it? What is it doing? And what can we learn?
Well,
Something
first, can you pronounce the name?
I actually never did know the name, so.
Okay. Pseudolore is the best
Pseudolore, of
pronunciation that
course.
we can come.
Yeah.
It was a challenge with Hagaput as well, trying to get my mouth kind of pushed around that during anything with TV. So Pseudolore has passed through CNMI, and the damage that it caused is extensive but not massive. So it came across what we would understand as a Category 2 hurricane, but what is a typhoon there. So we saw tin roofs or sheet metal roofs that were blown across. Some trees were uprooted. We did see we saw one that we were able to prove a sinkhole with subsidence occurring under a road. So the storm surge came through and actually took out the area under a road. We always tell people to turn around, don't drown, because you can see that roadway covered with water, not knowing if it's actually there. So we did see some damage in that light, but really it was not as bad as it could have been. What we did see was incredible preparedness on behalf of those living there.
Interesting.
You don't see lawn articles thrown everywhere. You don't see lawn chairs, propane tanks, grills tossed across the island like you may if you see a community that is not properly prepared. They took the correct actions. The tropical cyclone was not as bad as it could have been, and it's out of the area. And as Owen and I were looking at just this morning, as soon as it exited CNMI, it rapidly strengthened. So we don't know whether or not to say that they were lucky or not, but the atmospheric conditions just west of the islands actually turned it into a super typhoon, a scenario that could have been much, much worse for CNMI. So it was not too bad, extensive damage, but they're ongoing with the recovery right now.
So what did they do to prepare to make you say that?
When I looked through the pictures of the damage, which are only available through local media right now, FEMA is still en route, Coast Guard is still, actually, the Guam National Guard is there and the Coast Guard is there as well. But in lieu of any official pictures, I was looking through to try to pick out, okay, is there lawn toys anywhere? Are there grills? Are there cars that are tossed about? And there were a couple, but you could see that everybody had bolstered down what was in their backyards. Any articles that might have flown around, might have damaged, were actually well taken care of. When we look at Hurricane Ivan in 2004 along the Gulf Coast, a lot of the damage caused by that storm was the initial storm surge coming through, taking those unsecured items and knocking them against the infrastructure past that. I didn't see that with this. Now that might be disproven later, but in the images that I looked at through local media, it looks like they were very prepared.
You know, this teaches me something, and that is that part of this whole topic of forecasting is looking back to the history of earlier storms.
Mm-hmm.
You need to study, as you obviously have, earlier storms in order to get a handle on where this might go, what the possibilities are, and what the preparation is. It's a forecasting device. Just look at what happened before.
Mm-hmm.
So interesting.
And what Tom mentioned, one of the interesting facts about this typhoon is that the rapid intensification phase occurred the day after it passed through Saipan. And so, in other words, if those conditions that led to that rapid intensification happened just a day earlier, we'd be talking about a completely different set of impacts to the people of Saipan.
When does the wind get dangerous? I mean, so on the one on Guillermo, it was like it was 85, I think they talked about, and then some other 65, I can't remember. When does it get to be a problem? How fast is a problem?
It's a relative question. So if you have, let's say, a tent outside and you have an event going on, a birthday party, it gets dangerous about 30 miles an hour. If you're driving an ambulance, 45 to 55 miles an hour. If you're just talking about tropical storm strength winds, which is kind of the metric we like to use to warn people to at least evacuate, start taking preventive measures, we look towards that threshold. But when we need to decide one boilerplate wind speed, you can. We saw that just yesterday near Chicago, Illinois. Unfortunately, a fatal incident where we had a windstorm come through. and ahead of the most severe winds, ahead of that 58-mile-an-hour severe thunderstorm warning, we actually saw wind speeds that damaged a tent that caused a fatal incident. So the idea that we have one wind speed that will be dangerous, will be deadly, is incorrect, and that's what Owen and I are working strongly with our other federal partners, National Weather Service and FEMA, to allow people to think more critically about what they're doing to understand how they're vulnerable to weather, to define it better as a hazard for them.
Could I say that, say, 85 miles an hour in City A, which has certain kinds of architecture, and City B, which has maybe older, less defensive type architecture, is going to be more risky in City B than City A. In other words, I make that critical analysis you were talking about based on sort of a general conclusion about what's going on in one area, one geographical area, one city, as opposed to another. I mean, and announce that.
Yeah, you're
85
talking about the exposure too,
Yeah.
about
Yeah.
the nature of the building that's there and how sturdy it is, and so it's not just the forces of the wind, but it's also windborne debris that can
Right.
cause
Lawn
problems
chairs.
as well. Lawn chairs or other items as well too that become hazards as well.
So-
And then that's why it's really important to look at building codes and to look at how roofs are attached to the structural elements of the building. And-
Like we saw in Kauai,
Right.
all the roofs came off because they weren't attached, and then now there are roof guys running around selling you all kinds of special
Hurricane
brackets and
clamps
clamps and
right,
whatnot.
right,
Yeah.
Right.
Yeah.
So, but that's part of it, right? So, and in the training courses that we do, we do cover the types of things that you can do to make buildings more resilient against wind damage. But that's not the only type of damage that can occur. I mean, there's also the potential for flooding, for heavy rainfall, for flash floods, for a storm surge along the coast, and oftentimes that's as we saw even during Isel, that was a pretty significant damage in the coastal areas. And so,
Yeah. Well, suppose I give you Hawaii, or I give you Honolulu, as opposed to Portland, Oregon. Same storm. Which one is more exposed? I mean, Hawaii, you have the hills and the water runs off the hills. You have these drainage canals and the like Alawai, that could be, a feature in what happens. You have the ocean. And I guess the topography in general, whatever it is, and you have the way things are built. Could you assign, for example, a risk number to this city and say this city, with all of those factors considered, is a number 7, but Portland, Oregon is a number 5?
that's really challenging because, as Tom was describing too, that the human element plays a large measure to this. I mean, at one level, it's straightforward if you're talking about buildings and structures and whether or not they're building codes and whether they've been updated and so forth. But beyond that, there's a lot more about warning systems, about whether people heed the warnings, whether people evacuate, whether they move to higher elevations when there's flooding, whether they go to shelters
Right.
If their homes can be damaged, whether they do things like pick up all the things in their yard that could become projectiles and store them. And these are all things that really could impact
A lot of
an outcome.
factors.
Right.
And one thing that we're looking at now is as the new generation, as the millennials start to become the generation that I don't want to say is running town, but the ones that are starting to come into new higher level positions, who might be issuing evacuation orders, who might be working as emergency managers, as first responders. What's the last hurricane they've gone through to base their expectations for this off of their own experiences? So, Jay, have you weathered any hurricanes before?
That's an interesting question, because I've been in Hawaii for 50 years, and I can't remember a single one that affected me.
Can you think of the...
7, you're 59.
we have the running list that's going now.
82.
I can't remember a single one that affected me personally.
I'll raise you a different question then. What is the fastest
I
wind
think I
speed
was
you've
traveling
been?
at the time.
The fastest wind speed you've been in before?
It was way up there. But it was not over 100 miles an hour.
Right.
Yeah.
One of the things that I found so interesting through going through teaching these classes, we've done them in Kauai, You've done them in Washington, D.C. Is Owen had a point with Hurricane Ike, the difficulty to stand up in strong storm force winds. You don't have that understanding unless you've been in it before. So those of us who have been lucky enough to, I say lucky, to have experience to be able to make responsible decisions and add to the social preparedness of a city can help benefit the community by having that experience.
Isn't that the NDPTC's job? You have to.
See, we could have described it, but you just said it right there now.
You have to show, if they weren't there, and a lot of them
Right.
weren't, I mean, and there's a lot of people who never had the experience or were close to it or even saw it on TV, really, and, you know, the kind that scares you. Somehow you have got to inculcate in them what it is and what kind of judgment they ought to apply. And that's hard, because it's the same thing as studying the history of other storms. It's studying the personal experience of other storms and building that into reactions. Yeah.
Communicating the hazard is really difficult, and I realized that firsthand with that Hurricane Ike example, because I had studied, I went to Cornell University, did my degree in meteorology and atmospheric science, and then was already a master's student at University of Oklahoma. I had studied the topic for 6 years, and yet my first time standing inside a hurricane collecting data at landfall was near Galveston, just inland from Galveston, Texas, during Hurricane Ike. And being outside, actually collecting and measuring the wind speed data and feeling the winds was a huge shock to me, because the winds, as they approach 50 miles per hour, it becomes hard to breathe. I had to put the coat over my face. It became really, really difficult to stand up, and anything above 60, the rain started to sting. It actually hurt to stand outside. You know, and we picked an area where there wasn't any debris, so there wasn't much danger of that. But that's what really hurts people a lot of times, is debris, being struck by debris. And anything
Your
even
way
near
of
hurricane
describing
force.
this is pretty scary.
Yeah, it is, and that's something that is really hard to communicate in a training course or in a
Right.
textbook, and even on video, because you see the wind, but you can't really feel it.
Well, that must be an interesting, you know, to go back to your story about the tornadoes in the Midwest, whatever. If you're standing there and you feel this wind around you, and then you imagine in your mind's eye, sort of a kinetic analysis, that if there was a missile, projectile, whatever you say, and it was heading at you at the speed of that wind, you'd be in deep kimchi. And
Never heard that before.
so,
steal that.
you know, and that's pretty scary all by itself, to stand there and know that if you're in the line of fire, you're going to get hurt or killed. And that adds a whole new element of fear to it, I think.
There is the effort across the nation to lead weather preparedness in forms of doing a classroom activity. Let's say a FEMA class is standardized. The ones we produce are standardized across the entire United States. The benefit you have of having a teacher come in and talk to you about it is having, or in the small class environment I should add, is having the ability to talk about those experiences. So Owen and I know the theory of weather like the back of our hand, but the experiences that those local communities bring to actually share that experience is what's so beneficial about what Karl is doing with NDPTC, what they've been doing for so many years, and what they're now starting to do with even indigenous populations across the U.S. They may not have perhaps, you may be going into a community, a rural community that may not have a meteorologist there. But to hear that they understand the weather so well because of the experiences that they've had, that rival a degree, and in some places actually overcomes a degree, is incredible.
Yeah. Well, we're going to take a short break. We're going to come back and talk about the factors going forward, like El Nino, how that affects things, and the relationship with climate change. Well, I think two things are clear. One is, from the discussion so far, we need not be all that concerned about Guillermo or the one you mentioned in Saipan that I can't pronounce. Okay. The other thing is, you know, we should be respectful, if not affectionate, to all our meteorologists. They are going to be increasingly important to us. You're going to have friends everywhere. You'll see. We'll be right back. We're going to discuss El Nino in a minute.
Ted Ralston, folks, host of our show at ThinkTech Hawaii called Where the Road Leads, where we talk about technology influencing the future of Hawaii. Technology, of course, is the art of solving problems. We always bring in interesting and informed guests who can see from different perspectives and different points of view how that future might unfold and how technology can assist us in getting there. So once again, join us 4 o'clock to 5 o'clock on Fridays. Ted Ralston, your host. And please,
Hi, I'm Jay Fidell. That's Ted Ralston. You know, Ted is the host of Where the Road Leads. It shows every Friday from 4 to 5 p.m. It's about technology. It's about how people collaborating and solve problems with modern technology. It's where the road leads. We all know that. We should all be listening. Join us there, 4 to 5 p.m. every Friday. Now, what about that do you agree with?
all of it.
I knew he'd say that. Aloha. Say aloha.
Aloha.
Good.
Aloha, my name is Josh Green. I'm a senator from the Big Island in the ER position. Every other Tuesday, I get to host a show here on the ThinkTech program about healthcare. We call it Healthcare in Hawaii. It's really enjoyable for me to bring other healthcare leaders from around the state to talk about our pressing issues. Hawaii has long been the health state, but we need to keep up the momentum, the inertia, and with your help and with your participation, we can come and share all of the big issues that are pressing day to day. Thanks for joining us every Tuesday, alternating weeks from 2 to 2:45.
Okay, we're back. We're live with Karl Kim, Owen Shieh, and Tom Bedard. And now in this part of the show, we're going to talk about El Nino, and we're going to talk about climate change and how that affects forecasting weather and climate and hazards. We live in a different time, you know. I mean, really, it only came up with Al Gore's movie, as far as I'm concerned. And here we are. The planet is devolving under us, and you guys get to see that and do metrics on it. Whoa. So what's happening, and what are these? How do these other elements? How do they all connect and exchange with each other?
Well, I think El Nino came a little bit before Al Gore.
Right.
So,
Didn't he invent the internet too?
yeah, right.
Something like that.
So there are a lot of different factors out there, and that's something that is often confused in the public dialogue, is what all of these different terms mean, especially when you throw politics into the mix. It becomes really confusing. So climate change, there's different ways we can discuss it. So long-term climate change that really came to the public mind recently is talking about the human impacts as well as some of the natural effects, the natural cycles, or what we would call climate variability would be kind of a subset of that. So in other words, if humans weren't around contributing to CO2 greenhouse gas emissions and warming the globe, what would be left? And a lot of it would be the climate variabilities, of which El Nino is a part. So El Nino is one of the many types of variabilities that exist in the climate system. So what El Nino is every 2 to 7 years or so, every few years, the trade winds across the Pacific will weaken. And when that happens, all the warm water near the surface of the Pacific Ocean along the equator actually has a chance to slosh back toward the east when the trade winds aren't always pushing them over to the west. So when that happens, the waters warm off the coast of South America, and the eastern and central Pacific waters warm. And when that occurs, that changes the global weather pattern. We get more tropical cyclones, more tropical storms and hurricanes in the central and eastern Pacific.
It's not just the Pacific then.
This affects the whole globe. And so during an El Nino year and during the winter, the impacts are stronger or are more evident. The west coast of the United States will typically get more rain. They'll get heavier rain, which could be helpful for the California drought this year, actually, hopefully, crossing our fingers. Southeast U.S. will actually experience more severe weather in the winter. So a lot of tornado outbreaks often occur during El Nino winters in the southeast. Then we have hotter, drier conditions and wildfires across Australia, across Southeast Asia. And so these are global impacts. And these occur, like Karl said, long before Al Gore, long before climate change really became an issue, because these things occur naturally. So of course, when you put these two parts together, well, how is climate change affecting El Nino? How is climate change affecting hurricanes? These are the big research questions that are now attempting to be tackled by a lot of scientists around the world.
Yeah, and it's global. Yeah, it really sounds very interesting. I wonder if SOEST is doing that. Is anybody at UH doing this kind of research? This is fascinating
Oh
stuff.
yes, of course. Sure. And a lot of the El Nino work was actually pioneered at University of Hawaii.
Yeah.
Just because we're here, it's a very strong oceanographic and meteorological research university.
Yeah, and it's not just the changes in weather, the changes in precipitation, that I think it's also really important to look at the impacts of those changes
Yes.
on society. The
Yes.
impacts of increased drought, increased likelihood of wildfire, and then also changes in agriculture, changes in fisheries,
Water.
water supply, and how these sorts of changes can have other types of effects. So you're having a drought at the time that you're have a water shortage and an increased temperature. It drives up the consumption of electricity. More people are using their air conditioning. It also impedes the ability to fight fires as well too, because of the water resources are being taxed. So there are many, many implications of this that we need to think about, particularly in this region, as you know, which has had among the highest rates of urbanization and growth in the world. So I think that these are important topics to research, not just the causes of these changes, but also the impacts.
Yeah, meteorology is climate, and climate change is climate, so you're right in the middle of it. You know, what happens now. And Karl, as an urban planner, interested in every effect that happens, not only in the structure and operation of the city, but socially among the people. The world is, you know, we always knew the world changed quickly, but now it's like on steroids, you know, because these things will affect the way the world changes and speed it up. And you guys are right in the middle of it. I envy you that. So what kind of research do you think is the most useful research to determine exactly how these forces work? For example, Owen said that the El Nino comes between 2 and 7 years, okay? Why can't you tell me exactly when it comes? What do you need to know to answer my question?
That's a very good question. The El Nino research right now is really focused on prediction and predictability, because last year was a great example. A lot of the computer models that the latest and greatest of our technology was hinting at a possible El Nino developing, well, nature didn't want to cooperate with our prediction, right? I know it's kind of backwards to say it that way, but that's essentially what happened. Was an El Nino was attempting to form, but then it didn't. It kind of continued on to this year. And so it wasn't until this year did the El Nino officially become announced. And so it is here, and the forecast is for it to continue through the rest of the year.
Don't you agree with me? There would be a reason for it to come early or come late. There'd be a reason for it to be 2 years or 5 years or 7 years. And if we had the data from all over the world, all oceans, all skies, all mountains, everything, I will never get this, not quickly anyway, that we could determine what that reason was, that we could sort of connect all these phenomena together and predict so much more. Huh?
Yeah, so actually your keyword there is determine. So deterministic forecasting is something that is an ideal situation, right? Where if we had all the data in every square millimeter of the atmosphere and we can ingest all that information, then theoretically, given all the equations that we already know, we can give a forecast however long into the future. But because we don't know all that information, then chaos theory, the idea of the butterfly effect, the idea that an incomplete picture now gives us an incomplete forecast into the future, and the errors grow with time into the future.
Further on. Yeah.
That's the problem that we have in meteorology, is we know we can't have a perfect picture of what's going on now, so we can never have a perfect forecast. But we can get as close as we possibly can to it, and that's the edge of the research right now.
So what would you like to see? What would you know, if we take just a sort of a small step forward, what would you like to have to do better forecasting on things? What information, what tools, what techniques?
I'd like to start with probably a free cup of coffee. If we can start
Always
forecasting
helps,
shifts
always
up that.
helps.
Okay, there we go. Now we're going to start getting a better forecast. So this comes better with a story. So the one weather sensor that we have at that passed right under the eye of Pseudolore registered heavy snow. When we think that perhaps the eye of the typhoon was passing directly overhead. The sensor may have malfunctioned, may have not. The data may be saved, it may not. We don't know yet. But the fact is that our weather sensors on the ground at airports, what are supposed to be the most reliable, don't work. They are efficient up until a certain threshold, so we were able to capture some wind speeds with the typhoon, but not what we need. Those go directly into weather models. If we could start at the simplest level and have better weather instrumentation, then we'd be able to produce better forecasts.
Okay, we're almost out of time. But I do want to ask you guys to comment on the name we gave this segment, namely Planet of the Adapters. What do we have to do, us people, to adapt to this, this huge and accelerated change in climate?
In the past, we used to talk about hazard mitigation, which was just reducing the harm from hazards and threats. But what we are realizing is that we have to live with these threats and hazards. And part of what that involves doing is both understanding the science as much as we can, but also making changes in our systems, making changes in the way that we live our lives, the way we manage our affairs, the way that we run our businesses, so that we're better able to adapt to these sorts of
So what's your advice to the average person? There's the camera, that one.
That one right there?
That's the one.
Okay. Well, my advice is come take our classes at the Preparedness Training Center. We've trained more than 16,000 people across 200 cities in the U.S. We need to do that. We need to train more in Hawaii. And we think training and education is the key to adaptation, becoming the planet of the adapters. And we have all kinds of training courses, not just on hazardous weather, but also on coastal threats, and we have a social
all those
media class.
implications.
All these different sorts of ways in which we can adapt to these sorts of hazards and threats, and save lives, reduce injuries, reduce the property damage that occurs, reduce the amount of disruption that occurs from these storms, and be better prepared for these types of events.
Saving lives is the part that got me.
Right.
Okay, Owen, what is your suggestion? There's your camera.
So for the public, my suggestion is that going forward, for the next generation, we can't deal with the natural hazard adaptation problem in a stovepipe sort of way. We can't just study science. We can't just study social science. We can't just study one field. We really have to be interdisciplinary. We have to think of science and the humanities as two sides of the same coin. That's something that really has struck me in the last few years is what's necessary, because we see time and time again with different types of storms that when we only focus on just one thing, even if we do one of those sides of that coin very well, the system still breaks down. So we really need to better understand communication, better understand society, and also continue improving the science and making sure all of these different groups talk to each other.
Wow,
that was
that's
great.
very profound. Yeah.
I don't want to follow that. Don't make me do this.
Come on.
Okay,
Sorry,
so
Tom.
I'm switching
That's your
cameras
camera
now.
there.
Okay. My advice for the greater world is trust the experts. And if you don't trust the experts, study and experience enough to become one. And the second part of advice is don't use the term polar vortex. Polar vortex is not a thing. We're trying really hard to get rid of it. Please, that's a second bid. Thank you.
Thank you. We could go on. This was a great discussion. Thank you, Karl. That's Karl Kim, Owen Shieh, and Tom Bedard. Thank you, gentlemen. That was a great discussion. I loved every minute. Aloha.